Hello, our most valued student. My name is Confident and welcome to our revision guide, and this is the ultimate guide. We are looking at the topic analytical geometry for you guys who are doing your grade 10, and I will dive straight into the lesson. So if you are doing analytical geometry in this particular term, this will make some sense to you. So this is the lesson. Let's start with the distance between 2 points. That is the first part. Now, what sometimes the exam comes with is that they don't give you these formulas. So you need to know the formula for the distance. So how do you find the distance between 2 points? Is the formula for, let's say for example, you have got a Cartesian plane like this, right? And in this particular Cartesian plane, you have your x-axis and your y-axis. So this is my y, this is my x. And then let's say I have a point from this, like this. And that particular point, there are two points joined by the line. Let's say A, let's call it xa and ya. So those are the coordinates of point A, and the coordinates of point B, let's call it xb and yb. So let's say this is 2 points A and B, and you want to find the distance between these 2 points. Now, as I said, they don't give you that formula. So what is the formula saying? Saying distance of AB, you write it in small there as a subscript, is equal to square root of, I'm not going to prove it, I'm just going to apply it. So what you do, you take, for example, xb, you say xb minus xa, and then close the bracket, you square it, plus, same thing with the y, you start with yb, don't start with ya. If you started with xb, start with yb, minus ya, and then you square it. This is the formula for the what? For the distance between 2 points. That's the formula. So always remember this formula. Is the difference, that is x-axis and the y-axis. So you're saying xb minus xa, but you square it. And then why do you square it? In a way, it comes from the theorem of Pythagoras, but as I said, I'm not going to prove this one for this, but just to apply it. Let's look at an example. For example, here it says in the diagram, the vertices means it's another way to say the corners. So the corners of triangle, that's triangle ABC. So you can see that they gave us a triangle here. Just to make it clear, this is the triangle, and it has got A 0.23, B 57, C minus 26. It says show that ABC is an isosceles triangle. Now, what is an isosceles triangle? It is a triangle with 2 equal sides. For example, if I can draw an example of an isosceles triangle, it will be almost something like this. And then when you're saying it's isosceles, it means this side is equal to that side. That is an isosceles triangle. It's a triangle with 2 equal sides. If it is now 3 equal sides, it is called an equilateral triangle. Remember the 2. But if it's 2 sides, it's an isosceles triangle. Now look at this. If they're saying show that ABC is an isosceles triangle, what they're trying to say here is, looking at these, just find the distance. If you can find the distance between AB, maybe, and BC or AC, if 2 of those are equal, it means it is what? It is an isosceles triangle. So let's do it from here. We said we know, let me write the coordinates. A is 2, 3, all right, and then B is 5, 7, and C is minus 2, 6, right? So now we don't need that for now. So if I can take these, it's up to you how you want to do it. You can start by saying, okay, let me find here distance. Let's start by saying distance AB, right? So what you do, since this is A and B, you come here, you make this your XA and your YA. See how it's like? And then your XB and your YB. And then you cut that formula to say equal to square root of xb minus xa. What do? You square that, close the bracket and square, plus yb minus ya, and what do? You square that. Okay, so now you just substitute where there is xb. You see xb is 5, so you say square root of bracket 5 minus, what about xa? It's 2, but don't forget you put a square, plus yb is 7 minus 3, and then you put a square. Are you with me? So that is the distance of what? That is the distance of AB. So we move on. Let's find, I can calculate this later. Let's find the distance of let's say AC now. So what I do here, I will have my x, but it's for C, and my y for C. So you got the same formula, equal to square root of, it's better to write the formula, guys. So since I want AC, so I can say xc, start with the C, minus xa. What do? You square it, plus give it a space there, yc minus ya, and then you square that. All right, you just have to be consistent. So what is distance of AC? So let's start with that, which is square root of xc is what? Bracket minus 2, and then what about xa? Minus 2, and then you square it, plus yc is 6, and then minus ya is 3, and then you square that. Are you seeing that? So that's how you're calculating all these distances. Let's find the first two for now. We'll do the other difference then. So remember, the aim when you're calculating the distance between 2 points, the aim here for an isosceles is to look at the one that is equal. So if I say square root of bracket 5 minus 2, and then I square that, and then plus here it's 7 minus 3. All right, and then I square that, equal to 5. So here I'm going to get 5. What about the other one? Square root of bracket negative 2 minus 2 squared, and then plus 6 minus 3 squared. The first one gave us a 5. This one is also giving me a 5. So here what you write? You write 5 what? It's 5 units. We don't know whatever units it was. And then even here it's 5 units. If you're dealing with centimeters, you'll say 5 centimeters. If you're dealing with meters, you'll say 5 meters. So this is this. Already, I don't need to go further, but I will do it. But I didn't need to go further to find this distance. Distance of, this is not, I found AB, AC, and let's look at BC now. I didn't need to find this distance. So it is equal to square root of bracket, I will say xc minus xb. Guys, by the way, it's not every time that you start with the alphabetical order. You can even just say xb minus xc. It's still fine. Then you square it. Plus, now you follow with y, but you maintain. Don't say yc minus yb. Say yb minus yc. Well, with the distance formula, the answer will be the same, but I don't want you to get used to interchanging these for the sake of your other formulas that are coming. Distance formula, it doesn't matter as such because it's a square. So the square usually evens out because it's not in a way affected by the negative sign. But when you start finding other things like the gradient and the midpoint, you might have an issue. Now let's look at this. Let's look at xb, which is equal to square root of xb. It's 5 minus xc. Now look at this. Be careful now. This is where most of you sometimes might make an error. The formula says xb, which is my 5, minus, the formula has a minus, but xc also has a negative. Do you see that? So you write minus, and then you say minus 2, and then you put a squared. The calculator will do that for you. Don't worry about the minus. And then what about yb? It's 7 minus yc, which is 6. And then you square it. And then let's find the answer there to see what it is going to give us. Alright. So you've got a square root of bracket 5 minus 2, just like that. squared plus 7 minus 6 squared. And there 5 root 2. So this is 5 square root 2 units. I know I could round it off, but automatically it shows me it's different. So if I'm plotting this kind of triangle, look at this. It's a triangle. Just as an example, okay, let's come here to the original. AB, you can say that AB here. If I conclude, therefore AB is equal to what? The AB, distance of AB and distance of AC. So AB is equal to AC. So if I can come here to the original now, you can see that when I look at that AB, this distance is equal to AC, is equal to that distance. So you see, that's the isosceles triangle now. Are you with me? So they show that triangle that is an isosceles triangle. Now look at the next one. It says calculate the perimeter of triangle ABC correct to 1 decimal place. Guess what? What does the word perimeter mean? Perimeter means distance around the shape. By perimeter is the total distance around the shape. Total distance around the shape. So what simple it does is, I did well by finding everything here. So when you're talking about perimeter, we are going from, we are saying here perimeter P is equal to AB, you say distance AB plus distance BC plus distance AC. You see, that's the distance around that shape. So in a way, I'm just adding this. If I'm looking at perimeter, I'll say here perimeter is equal to of triangle ABC is equal to, we are saying 5 plus 5 plus 5 root 2. Are you seeing that? You are adding the distance around that particular shape. So in here, that's what you'll be doing. So when you do that, you say 5 plus 5 plus 5 square root 2. And what does it give us? 10 plus 5 square root 2, which is 10 plus 5 square root 2. You might want now to simplify that to say what is the 10 plus 5 square root 2 equal to the ST, which is 10.2 decimal place, 17.07 there. Alright, this is whatever unit that they give you. So this is now the perimeter, which is the distance around the shape. So guys, that's what you use when you're looking at the distance formula. Let's just look at a few examples and how they bring about these questions that might make sense to you. It says example here, it says show that C is equidistant from the points A and B. Now I'm not going to draw exactly the accurate Cartesian plane, but what we are doing is, let's say you have got a Cartesian plane like this. It's just a sketch, okay? So this is my Y and this is my X. And then let's say I have a point. Now they're saying, where is point C here? Point C is 2, 3. It's positive. Let's say I've got my point here. That's my point C as 2, 3. As I said, this is just an estimate. And then I've got my point A. Okay, let me start. Actually, I don't want to do C. I want to do A and B first. C, I'm gonna see it later. A, point A is 3, 6. Let's put the 3, 6 actually there. Say A is 3, 6. Remember, this is an estimate, and B is negative 1, 4. Negative 1, X and Y. X is negative, but Y is positive. So we can actually have this as my B minus 1 and 4, just a sketch. And then if I join these 2 points, look at this. And then they are telling me there is a point C that is equidistant, meaning C is at the center, the distance there. That's my C, that's why it's 2, 3. But what does it simply mean? It means if I can measure from here, for example, from here to here, see this distance? And then I find that particular distance here. It is equal to that distance here. I think that's what equidistance means. So if this distance, for example, is x, that other distance also will be equal to x. So they're saying show that. You have to show that C, the distance from, in other words, they're saying the distance from B to C is equal to the distance from C to A. You can write it in alphabetical order to say BC is equal to AC in this case. Are you seeing what's happening? You're showing that. And remember, when you talk about distance, you're automatically talking about the distance formula. So if we look at the distance formula here to say what is distance BC, D of BC, you got that formula to say, remember, it's x of what? C minus x of B, then you square it, plus y of C minus y of B, and then you square it, which is equal to, we go to x of C. Now x of C, the x-axis is the 2 there, and then x of B, the x-axis is -1. So let's look at B and C. Remember, I'm looking here at B and C. Okay, let me write it down as B so that you can see what I'm talking about. B is -1, 4, and C is what? C is 2, 3. Alright, maybe to make sense, 2, 3. So what I have is, I'm saying this is your XB, this is your YB, and this is your XC, your YC. That's what you are using there. So if I say square root of XC, which is bracket 2 minus, now I've got minus of the formula and the minus of XB, which is minus 1 squared. If you can do that, you're good to go. Plus YC is 3 minus YB is 4, and then you square that. Alright, then you find that particular distance to say what is the distance. You say square root of bracket 2 minus 1 squared, are you with me, plus bracket 3 minus 4 squared. When you do that, you're good to go. Square root of 10. So we have got that distance BC being square root of 10. Now we have got the next coordinate, which is our what? Our A. So what was our A here? I think our A was 3, 6. 3, 6. And then I'm going to use it to find now the distance AC. So if I say D of AC is equal to, you do the square root, you can say XA minus XC, it's up to you, anything, or XA minus XA squared, plus plus Y. Now you must maintain the A minus YC, but you put a square. I think that. Now you come here and say, what is XA? There it is. So this will be our XA, this will be our YA. So XA is 3 and XC it's 2. So you see that it's 3 minus 2. So I'm gonna have here square root of bracket 3 minus 2, I square it, plus YA minus YC. YA is 6 minus 3 squared. 6 minus 3, and then I square it. Again, get comfortable with the calculator there, because that's the one that is, you have to use it in this case. 3 minus 2 squared. You have to just do this once, you know. I think I left out that. And then plus what? Oh, sorry about that. Let me start afresh. Oh, there it is. Plus 6 minus 3 squared. It gave me square root of 10. You see? And then what did you say the condition was? If BC is equal to AC, you can say BC, you can conclude BC, the distance of BC, 10 units, is equal to distance of AC, which is equal to 10 units. Therefore, C is equidistant. You see, equidistant, meaning C is at the center. C is at the center of the line AB. That's what it means there. Alright, let's just move on for the sake of time. It says example here. Let me see if time allows, and look at the next one here. Alright, so the example here, look guys, my time does not allow. Unfortunately, my time does not allow. I need to stop this one, but this is the next part that I wanted to give to you, to say given the points blah 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 blah, determine the values of x if P is equidistant. Very important part, very important part. Look at the next one again. On equidistant point, it was saying what, example, C is a point 1 minus 2. The point D lies in the second quadrant and its coordinates that. If the length of CD is that, determine the value of x. Another important one. This is where now you involve the quadratic equation of factorization. I want you to follow up in the next lesson. Of course, in the coming lessons we'll do a midpoint. In the coming lessons we'll do the gradient. So I definitely want you to follow the series of these videos. It's going to be 3 parts if I'm not mistaken. For now, we have come to the end of our lesson. This is the 24-minute lesson, the mathematics for the underdogs. An underdog is someone who says, please take your time, allow me to go with you slowly but surely, so, and I know when I master it, I'm going to excel. So that's why I take my time in these lessons. We've come to the end of our lesson. Remember, if you are not subscribed, it means you're going to miss out. Subscribe so that you don't miss out. Thank you.